Alan Boss, who I think everyone would agree is an expert in exoplanets and an advocate of finding them, says he was hardly convinced this is at best a candidate planet. Same with the Moreau trio. And Lisa Kaltenecker at Harvard said the same thing. It says that your papers are way too model-oriented. Can you explain why you think everyone would agree when, why is it not just a candidate? How is this more proven than, why aren't these brown dwarfs?
Okay, well, I will have a chance to correct my statement and say these are objects that almost everybody can agree are planets. Skepticism is very healthy and necessary in planetary science. We've seen orbital motion of this object. The models are it's correct, there's always a model that you need to infer. The reason why we're here today is because the mass of the planet is constrained by the dust ring. So this is different from the other claims and the other past claims as well, where it's model dependent in terms of the brightness. So that's the reason why we're confident with the mass here. And I'm going to turn it over to Mark in a second to further that point. I will just bring up the triple system, where my remarks were that I think in time, everybody will agree that they're planets because there are 3 objects orbiting the central star, where we've never ever seen that in any star or brown dwarf system before.
I guess I'd add to that in general, when you're measuring planets by direct imaging, it's tricky to understand what the mass of the planet is. For example, if you look at a shipping carton, right, you don't know how massive it is just by staring at it. But on the other hand, if you see a small carton, you might think, well, maybe that doesn't contain an elephant. And in this case, I think we've seen a small carton. So it seems to me to be pretty deep in the pocket of the realm that we consider to be planet mass. Also, there is this second line of inference, which is that if you have a massive planet, it will stir up a ring. And we don't see a very stirred up ring. We see a pretty well sculpted, narrow looking ring. And that puts an upper limit on the planet mass as well.
I should just add that we conducted follow-up observations at Keck Observatory, the 10-meter telescope on Mauna Kea, as well as the Gemini 8-meter telescope. In both cases, obtaining deep images very similar to the ones Marois obtained from Keck and Gemini. At these wavelengths in the infrared, so we're measuring the heat of objects, we would, if Homo hot B had the mass of a brown dwarf or a star, it would have been easily detected from Keck and Gemini. But our result is a non-detection. So Homo hot B presently has only been detected at optical wavelengths.
Okay, let's go to our next caller. I believe it's space.com. Zena, are you with us?
Hi, yes, this is Gina Briner at space.com. Thank you. This question is for, I guess, Paul or Mark. After years of trying to directly image a planet, and I guess, there have been claims, but none have been confirmed, what allowed you to specifically capture Homo hot B successfully? Was it something about the planet itself? Anything else?
I think the key thing in this case was the fact that we had the Advanced Camera for Surveys coronagraph, and combined with that, after we discovered the disk, which ironically was discovered while we were trying to do a program looking for planets, we got an award of a significantly large amount of time, which allowed us to go very deep. So I think it's the combination of the performance of the coronagraph combined with the large amount of observing time we were able to put into this program to actually get deep enough to see this object. Paul?
That's right, and we're actually looking forward for the servicing mission in 2009 so that when the astronauts go up to Hubble, they have a chance of repairing the Advanced Camera for Surveys. Because what we really want to do is reobserve Homo hot B in 2009 and continue tracking it along its orbit. The more points we get along the orbit, the more accurately we can calculate its orbital properties and that gives us further information about its mass and its possible evolution.
I should probably add, Ed actually provided the funds to put the coronagraph into advanced camera several years after we'd started working on it, when the first radial velocity measurements were published. So it's a historical fact there.
Okay, we'll now go to David Perlman from the San Francisco Chronicle. David, are you with us?
Yep, I'm here. And first of all, except for the fact that I can recognize voices by either female tones or British accents, it would sure be nice to remember that us phone people can't always tell one from another if you all would identify yourself. A simple question, though, is what's the current count on exoplanets? It varies and jumps around, and just as background, who can say how many we've been
on the web
finding
the other day.
over the years? How many?
This is Mark Kushner, and I saw on the web 322. But some of those are candidates that'll probably go away.
Yeah, they're brown dwarfs, of course. Now, what prevents you from determining more precisely the mass of Fomalhaut B?
Well, this is Paul Callis from UC Berkeley. Like I said, once we get a third point along its orbit, we'll be able to calculate the orbital elements of Fomalhaut B more precisely. With just these 2 points, there's a wide range of allowable eccentricities and semi-major axes, which are 2 of the orbital elements that we look at. And essentially, we think that if we get deeper images in the infrared, we would eventually be able to see the glow from the planet itself. And for that, we're waiting for the NICMOS camera aboard the Hubble Space Telescope to come online. And we're continuing our work at Gemini Observatory, the Very Large Telescope in Chile, as well as Keck Observatory. So we're utilizing all the resources at our disposal to get more detections at more wavelengths in order to understand the properties of Fomalhaut B.
Okay, we're actually going to come back here, give an opportunity to any other questions. Paul, did you have any? Sir, did you have? Okay. All right, well, we'll wrap it up. Thank you for joining us. And, of course, for further information, go to www.nasa.gov. Thank you for joining us. And as you know, science never sleeps. Thank you.
Hi, I'm NASA Administrator Mike Griffin, and we're proud to celebrate NASA's 50 years of innovation, exploration, and discovery. Thanks for watching NASA TV.